Okay, I imagine after going through this table, you will become a little bit dizzy and a little bit confused. Oh, Mr. Wong, why do you tell me so much about the properties of different states? Okay, come back here. We are talking about internal energy, do you recall? And why do we have to study about the molecular properties of different states? Is we want to explain why among the three states, ice, water, and steam, why do we say that steam has most energy and ice has least energy? Okay, it is not difficult to accept this fact because when you have some ice, you have to provide energy for the ice, for example, burn it or leave it in a place hotter than 0 degree, and it gain energy and becomes water, right? And if you want to boil some water, you also need to provide a lot of energy to the water so that it gets into the steam state, right? So among the internal energy, we are now talking about different states, how the arrangement of different molecules lets the steam has the properties of higher energy. Okay, you can see that here it moves freely at high speed. They are very much separated, so gas is therefore having the most energy among these three. Okay, so let's say have a look at this magnetic toy I have. When they are close together, they are attracted by magnetic force, and I need to provide energy to separate them. Okay, this is not very strong magnet, but it's still demonstrated. I need to provide energy in order to separate them. So here, you need to provide energy to break the fixed state of solid to become liquid so that they can move around. And they are still held together by the force of molecular attraction. And you need to further provide energy so that the separation get larger and they are now free to move around. Okay, that is why we say this is the potential energy. Determining the change of state is one major reason why the internal energy increase. Okay, I have talked so much already. And the other part, apart from the change of state, the other part is temperature. Okay, it is about how fast the vibration occur. You know that these molecules are vibrating, and the slower it moves, the lower the temperature. The faster it moves, the higher the temperature. So this is the left-hand side part. Of course, 5 degrees Celsius has least energy. You need to provide energy for the water so that it gets hotter, become, let's say, room temperature. And you have to provide more energy for it to become 80 degrees Celsius. Okay, this part is related to molecular kinetic energy. And there are lots of words, but the one part you have to remember is that this thing, let me circle it in red, average kinetic energy. Okay, the temperature of something is measuring the average kinetic energy of a body. So let's say in this solid, there are slowly moving molecules, and there are very energetic and fastly moving molecules. But when we measure the temperature of this whole object, we are talking about the average kinetic energy of them as a whole. So if there are a lot of fast moving and some slow moving, the temperature is still high. Okay, remember this one. The temperature of a body is measured of a average kinetic energy due to the motion of the molecule of the body. Okay, and I hope this picture will help you. This part on the left side, the lower one is less energy, the upper one is more energy, and the type of energy it has. For temperature, it is the vibration of the molecule, somewhat like the spinning of an object. For example, I have a thing and it spins, the kinetic energy. And for the change of state, it is how far or how the separation of things. If they are separated, then they gain the energy of potential. Okay.